With the internal console bracket back from powder coat, I refit it, but in doing so notice that the alarm warning panel is very poorly aligned to the front of the console. This was apparent in the last video where I called out the fade line on the front of the panel being both off centre and wonky. What was not clear to me was just how far off it was going to be when refitted, and as can be seen here, there is a gap between the end of the panel and the console moulding. I do spend quite a bit of time trying to persuade a better fit, but the reality is that it's a long way off. To fix it, I'm going to need to modify the bracket, and for that I need to get in some material. In the meantime, I am going to progress with the wiring as best as I can. In part 3, I called out that the coils were incorrectly located on my bike, and that as far as I could determine they should be fitted behind the left side panel. Although I'm not sure on exactly how they should be fitted, I decided to make a new aluminium bracket to replace the existing one. This gives me the advantage that I can lay out the parts as I want. To make the bracket, I used some 6mm aluminium sheet, using the old bracket as a template for the outline and the 3 mounting holes. For mounting posts, I use a couple of stainless countersink bolts and turn up a couple of risers which I've threaded through a M6. I mount the coils vertically side by side, although I think that maybe they were originally angled. I also have a suspicion that these may not be the original coils, as they appear to be oversized. I also take the opportunity to ensure that the voltage regulator is positioned horizontally and not at an angle. I previously did a basic test on the ignition switch, but to refit it to the bike I need to identify which wires go to which connector. Its operation is basic with 3 positions: off with no contacts made, on which connects the input to all 3 outputs, and park which connects the input to the parking lights. Simple. Using my benchtop as a whiteboard, I work through the 3 switch positions to identify the contacts in the switch, and from that, using the wiring diagram and double checking against the loom on the bike, the relevant colours of the 4 connecting wires. The wires for the ignition switch break out from the main loom before the 3 connectors at the front of the bike, and now that I know where each should go, it's a simple job to plug them in. The spiral wrap on the wires is temporary, and there is also a rubber hood which will give some protection from the elements, which I'll fit later. The indicators are quite scruffy, the larger units being for the front and the smaller for the back. I'm not going to address the cosmetics now, rather I'll do that when I'm dealing with the bodywork. The screw that secures the mounting end ground point on one is missing, so I find a temporary substitute. For the rear indicators, you can see where I cut the wires when I took them off the bike. As I just need them working so I can test the wiring on the bike, I connect the rears to a section of chocolate block screw terminals, but for the front I can use the existing wiring. When testing, I find that one rear is dimmer than the other, this being due to a colour bulb being used, and that one front bulb is blown, so I replace both with new items. I do consider swapping the bulbs for modern LED replacements and swapping out the flasher units, but that can be a job for the future, unless I run into issues with the flashers when I test the loom. The switch for the hazard lights strikes me as being an afterthought, or maybe it was a late addition due to a change in regulations. I'll be generous and go with the latter. It's hidden away, as we can see here in this picture from when I bought the bike, mounted on the left headlight bracket with no label. With the switch on the bench, I give it a good scrub with isopropyl alcohol and note that one of the connectors has snapped off, which is ironic as it's easily the best quality electrical component on the bike. As a temporary fix, I solder a short piece of wire onto the broken connector and test it. It's a double pole single throw switch, so getting a replacement will be easy. With my temporary fix in place, I connect it to the loom for testing. I also connect the indicators along with their shoddy connectors to the loom for test. Like the indicators, I'll deal with the cosmetics of the tail light later, although I do pull apart and clean the 3-pin plug. A check with my power supply shows that both rear lights are working, but the brake light element in one bulb has failed, so I replace it. I've bought a new battery, the current day equivalent of the Moto Guzzi original. It's big, really big, but looking at the battery tray, smaller than the original item from nearly 40 years ago. It's rated at 30 amp hours, which reflects the load of cranking over a big V-twin. For my Cafe Racer build, I previously bought a very small lithium-ion battery that had just enough oomph to crank over the motor a couple of times, and then it was done. But I had a workaround for that. However, the standard charging system is not suitable for lithium-ion batteries, so it's back to traditional lead acid for now. I believe that originally it would have been housed in a box, but I don't have that. Also, in video 2 I mentioned the posts that the battery rubbers were mounted on, which I now see are not actually required, but I am going to need to figure out a way to properly hold the battery. I make some new cables for connecting the battery. The positive connects directly to the solenoid on the starter motor and the ground to the engine block via the bell housing. There is also a positive connection to the bridge rectifier for charging, which also connects through to the ignition switch. The frame is used as a common ground for the bike, and as we've seen, the negative terminal of the battery is connected to the engine block. The loom is grounded at one point here under the tank, which collects all of the returns from the front of the bike. That's the lights, indicators, starter circuit, horn, some of the console lights, and probably a few other things. Everything else backwards is grounded via the frame. I have two concerns. First being that I think the original design is going to be liable to ground faults, likely more so since I've had the frame powder coated and the ground paths rely on good electrical contact between the frame and the various brackets. Secondly, the loom ground point will be carrying a lot of current through this relatively light gauge wire. To deal with these issues, I run additional ground wires. The first from the battery to the loom ground point below the tank here. The next from the battery to the ground side of the bridge rectifier. Having closely inspected the rectifier, I can see that the top half of the chassis will be at the rectified voltage and the lower half grounded. The route to the lower half of the chassis being through this bolt here. Working from the bolt on the other side of the rectifier here, I run a ground through to the new aluminium bracket that holds the regulator and the coils, the ground being required for the regulator. I then run another ground from here for the rear lights and indicators. I will revisit this one once I've got the seat base back in place and cleaned up the associated wiring. Finally, I modify the wiring at the front of the bike by separating the ground for the dim and main beam lights from the existing connection and run a dedicated ground wire to the frame ground point. I do this by removing the two wires from the connector and then joining them together, and then run a new ground wire for the lights, although for now I have to bypass the plug until I can get some new pins. All of these new ground wires will be bundled up into the loom once I've tested it. Some may appear to be a little bit long, but I'm sure that I will lose some of that once they're bundled into the loom, and if not, it'll be easy enough to trim them back. With the exception of the wiring to and from the alternator, I've now worked through all of the major electrical components on the bike. Although I've not called them out in any detail, I have connected the oil pressure switch, the neutral indicator switch, the starter solenoid, and the horn. Regarding the horn, I think there should be two, but I only have this single item, which although it works, really is junk and will need to be replaced. I'll cover off the brakes in a separate video, but I can simulate the light switch operation for both the front and the rear masters. Next, I need to modify the bracket for the console so that I can refit it to the bike. And then I can test, as far as is practical without the engine running, the correct operation of all the electrical items, and in doing so, of course, the loom. That will be for another video, possibly next, or I may take another diversion to something else before coming back to this. As always, thanks for watching.